Hi guys, today is just the review overview. So I'm going to keep this video fairly brief. There's a lot of stuff obviously in this unit, a lot of rules to know. So that's what a lot of the information at the top of the page is here, is just reiterating all the different rules. You know, if you add or subtract on the outside versus on the inside, how that is a translation or a shift. If you negate on the outside or the inside, that's a reflection. If you multiply by a number on the outside or the inside, that is either a vertical or a horizontal dilation. So those are the three transformations in general. And then all the details as to, depending on what kind of number you have, how that affects it. Classifications wise, we talked about even functions versus odd functions. Even functions being symmetric with about the y-axis, so it looks like it's like a little reflection over the y-axis itself. You could write down as an extension, you know, that you would have the point xy and the point negative xy on the graph. And then for an odd function, same idea. Since negative x, f of negative x equals negative f of y, what that really means is if you have the point xy, you also have to have the point negative x, negative y on the graph, right? And then in terms of the applications, we did some with the parabolas, some with the absolute value. So where you have to be able to create your own equation. Expect to see a question like that on your test. Just putting it out there. So I'd like to do one of these with you. And then what I'm thinking is we'll probably just save the rest to be able to work on in class. So with that being said, the first one says create a table over this specific domain. So if they're handing you a domain, remind yourself you want endpoints on your graph. So into your y equals, we type in x squared and then minus 2x and then minus 5. And so I'm going to use my table of values here and kind of shimmy back up to see the values I want. So for part A, when it says create the table, that's exactly what I'm going to want to see. All right, not only on your review packet, but on, you know, a test question. So make sure that you show that work. So -1, 0, 1, 2, and 3. And then we have -2, -5, -6, -5, -2. So you'll probably notice that, like, hey, if you're given this particular domain, you're looking at a certain part of the graph over that domain. So let's graph that. So if we go to -1, -2, we have 0, -2, 4, 5, 1, -6. We got 2, -5, and then at 3, it comes back up to -2. So you get this cute little chunk of the parabola, and we'll label that as f of x. All right, create a table and graph g of x that equals f of 2x. All right, so for g of x equals f of 2x, remember, I would love for it to mean just 2 times all the x values, but that's not what it means. When it's on the inside, that literally means you're going to divide the x's by 2, right? Or I guess I could have just written x over 2. So it didn't mean to confuse you by the way I wrote that. But what it doesn't do is it doesn't affect the y's. So all the y values are going to stay the same. And part of the reason I wanted to do this one with you is when I give you a domain to start, then just let it morph as it does. Don't feel like you have to hold on to that same domain here. So what I mean is the domain now is going to go from -1 to -1/2. 0 cut in half is still 0. 1 cut in half is now a half. 2 cut in half is now 1. And then 3 cut in half would be 1.5. Right? I'm just looking at my answer key and wondering why I had slightly weird values. So, whoops. I had negatives on mine, so I wonder if the key that I posted online might be a smidge wrong. Whoopsies. The graph's right, but the number's wrong. Very odd. That's okay. I make mistakes. It happens. All right, so over onto your graph. If you have a different pen or pencil, here's a great moment to use it. So at -1/2, you're at -2. At 0, you're still at -5. At a half, we're down to -6. And then at 1, we're back up at -5. And at 1.5, we're here. So you get this teeny tiny little squished chunk of a parabola. And that is our g of x function right there. So that's this guy. And then the last part says create a table and graph h of x. So h of x equals f of x minus 2 and then plus 3. So what we want to keep in mind for h of x is that you're going to take the original. So you're going back to the original, and it's going to be a shift to the right 2 and then up 3. Now, because it does ask for a table, take a moment, create the table. And now it's up to you. If you want to walk the points over and then say what they are, that's fine. Otherwise, if I'm going to the right 2, that means I'd be adding 2 to all the x coordinates over here. And then going up 3 means I'd be adding 3 to all the y coordinates. So how you do it or what order you do it in is completely up to you. So if I add 2 to this would bring me to 1. This would be 2. This would be 3, 4, 5, ease peas. And then for the y values, add 3 to all those. That would be now positive 1. That would be -2. That's -3, -2, and then positive 1. All right. I don't know if I have another color floating around over here, so I'll stick with my blue. So I'm going to go over to 1, 1, and then 2, -2, 3, -3, 4, -2, and 5, 1. And then I'm just going to label that is my h of x. And I do have my highlighter still sitting next to me, so maybe I'll highlight that guy. So this is that graph right there. All right. So the takeaway, a little bit of practice, we have a horizontal compression. Here we have a translation. But again, if you are given a domain, start the initial on that domain. And then from here, move it as it needs to move. Don't feel that you have to only graph this piece for parts B and C. All right. Hopefully that helps. What I would like for the post-video question, I want to know what questions you want to go over, and don't tell me none of them. So look through it. And if you can't find a particular number, if you're not telling me like number 14, then maybe tell me a concept. Is there any concept that you would still want to do some practice with? So either what numbers you'd like to look at together or a particular concept that maybe you have a question about. All right. Thanks for watching, guys. Talk to you soon.